So this video is coming from the all request and dedication line, Google form, and a lot of people asked, can you review normal distribution, standard deviation? And so this problem was related to that. I'll talk about a few things that don't go along with this problem, but every time you see a normal distribution, you want to make the normal curve, or if they give you one, mark it on there. And remember that the mean is 1,000. The mean goes right here, and the standard deviation is 4. I label those on the picture before I even look at the rest of the problem. So there's bags of rice, and something that is 1,004 grams is the same distance away from the mean that something that is 996. So you could plus or minus 4. So if you were continuing, one standard deviation would be 1,004. Two standard deviations would be 1,008. One standard deviation this way would be 996, 992. Essentially, that's one standard deviation, but it's negative, and one standard deviation that's positive. Some of you just got called to the office. Okay, so now we can see what kind of questions that we're asking, and I'm going to review the calculator steps as well. Find the probability a bag of rice chosen at random weighs between 990 and 1,004. So 990 would be down here, and 1,004 is this one standard deviation up above there. So talking about all of that area. Remember that the entire probability adds up to 1 or 100%, depends on what you're trying to do. We're doing probability, so it adds up to 1. So there's two different distributions that we can look at. It's distributions where it's at. Inverse norm, where we know the probability, and normal CDF, where we don't. We know the range. So I know the range is from 990 to 1,004, and I know the mean is 1,000 and the standard deviation is 4. If you have a TI-83, it's going to look like this, where you put bottom or lower range, upper range, mean, standard deviation. So that's 0.835. And it doesn't save, change stuff to percent, so we'll leave it as a probability. 95% of the bags of rice weigh less than K. Again, every time you're doing these, make another curve. So if K is that value, 95% of them are less. That means my probability over here is 0.95. So this time I know the probability. So I'm going to do inverse norm of my distributions. And you enter the probability, which is 0.95. If you have a TI-83, it looks like this. Inverse norm, 0.95, mean standard deviation. That'd be 1,006. Should make sense, 95%. 1,000's in the middle. One standard deviation is about 34%. So 1,004 is about 34%. So if you think about 50 plus 34, that's 84, and then you go a little bit further to the next one. Find the value. Okay, for rice chosen at random, what's the probability that 1,000 minus some value and 1,000 plus some value, or in between there is 0.9. Again, make curve. Doesn't take that long. So the key here is that the 1,000, so some value over here, 1,000 plus A, that would be this value, and some value over here, which is 1,000 minus A. The probability of being in between those values is 0.9. So in this case, I have 90% right here. Now this presents a little bit of a problem because our calculator can tell us when we know the probability, it can tell us from left to right. And when we know the ranges, it can tell us the probability, but we're not starting at 0 here. So you have to use the fact that you know this whole thing adds up to 1. So that there's 10% left, or 0.1. That means there's 0.05 here, 0.05 here. So I'm really doing inverse norm with 0.05. And that's 993.4 here, blah, blah, blah. If I take that and subtract it from 1,000, that's the 6.58. That gets me that value that makes this true. So it really goes from like 993 to 1,006 or something like that. They just want to know that A value, which is 6.58. So last little quick review. Remember, distributions, norm CDF is when you know the range. You can go small or large. If you're going small and then you want it to be 0, that's your 0. If you're going big and you want it to be 0 or to be infinity, then make sure you make it big. Mean standard deviation. Use inverse norm when you know the probability, and it tells you left to right. Okay, so on this one, we were able to use 0.95 and get this value. Over here, we had to do a little bit of thinking. If you may want to notice here on this problem, this was not a coincidence. This was 95. This is 95. 6.579 was that value. I mean, you may or may not notice that. I didn't even notice that in doing that problem. That's it for now. I'll do another question later.